Hello, and welcome to the lecture on 3.1. Today we're going to talk about quadratic functions and models. Let's start with a definition. A polynomial function of degree n is a function of the form p of x is equal to a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus the pattern continues down to a2x squared plus a1x plus a sub 0. Now, you could think of this as x to the 0 as well. Remember, x to the 0 would be 1. But we've defined polynomials before. Quadratic functions we've also defined before. But quadratic functions, remember, are polynomials of degree 2. A quadratic function is a polynomial function of degree 2. So a quadratic function is a function of form f of x is equal to ax squared plus bx plus c, where a is non-zero. Now this does fit the exact same definition as a polynomial where n is 2. Basically, it would just be these last three terms where a2 is a, a1 is b, and a sub 0 is c. Graphing quadratic functions using standard form. The graph of a quadratic function is called a parabola. Standard form of a quadratic function. A quadratic function f of x equals ax squared plus bx plus c can be expressed in standard form. F of x equals a times x minus h quantity squared plus k by completing the square. The graph of f is a parabola with vertex hk. The parabola opens upward if a is greater than 0 or downward if a is less than 0. And this is what it looks like here. So if we have a graph, then we would have hk as the either lowest or highest point. So of course we're going to be graphing upward, so we'll have something that looks like this. The vertex is always the lowest or highest point depending on which way the graph opens. Here it's the lowest point, and it's at hk from this formula. If you can get your quadratic function to be in this form, then you already know what your vertex is, and you know whether it opens up or down. Now, this should follow from the section where we talked about graph shifting. I'll explain that in a second, as soon as I finish graphing these. So here we have hk, and this, of course, is a is less than 0 because it's opening downward. Let me show you how this follows from the section on graph shifting. Remember that we have the parabola y equals x squared. And it looks like this. Now the form f of x equals a times x minus h quantity squared plus k means that we have a stretching or shrinking factor of a, depending on whether a is greater than or less than 1 in value. And if a is positive, then it opens up because it's only the stretching or shrinking value. If it's negative, remember that we have to reflect it about the x-axis, so it would then be opening down. And then what we do is we shift it to the right h units and up k units. Now, depending on what h and k are. If h is negative, we would be shifting to the left. If k is negative, we would be shifting down. If we ignore hk and we only consider the stretching factor, then we would know that 0, 0 is still on the graph. So even after we apply the stretching or shrinking factor, 0, 0 is still here, whether it opens up or down. Now shifting this graph, that means that the new vertex will be at hk. Let's just assume all values are positive. I'm going to leave a as just 1, and we would end up with a graph that looks like this, where we have our vertexes at hk. Let's do an example. Find the standard form of f of x is equal to negative 2x squared minus 4x plus 1. If you recall, from this quadratic explanation, we can get f of x in standard form by completing the square. So that's what we need to do in order to get this into standard form. And if you remember from completing the square, we need an a of 1. So we have to factor a -2 out of the first two terms. So let me rewrite it as -2 times x squared plus 2x, and we leave a little space so that we can complete the square. And then we tack on this plus 1. So this plus 1 goes here, we leave a space here, but now we're completing the square on the inside of these parentheses. Notice that our a is 1, so we can actually complete the square here. Now if you remember the process of completing the square, you divide b by 2, and then you square it, and that goes here. So 2 divided by 2 is 1, and 1 squared is 1, so we're going to put a 1 here. So we add 1 here. Now the question is, what do we add or subtract out here? Because we need to keep this equation balanced. Right now we have f of x is equal to -2x squared minus 4x plus 1, and if we add this 1, then we're changing the function. So in order to not do that, we need to offset this 1 somehow by adding something out here. So you have to be careful. We're not subtracting 1 out here because we added 1, but what did we really add to the right side of this equation? Well, if we distribute this -2 back through, you would get -2x squared minus 4x minus 2 plus 1, where this minus 2 is corresponding to this 1. So what we actually added, if we resolve this, is we added a -2 by adding a 1 here, because it's multiplied by -2. Okay, so instead of subtracting a 1 out here, I need to add 2. Because what I really did was subtract 2 by adding a 1 here. This particular one will factor into x plus 1 quantity squared, so we get -2 times x plus 1 quantity squared plus 3, like this. And this is in standard form now. And what I'm going to do next is graph this. I know it's not a part of the problem, but I'm going to graph it anyway. So my hk, my vertex, is going to be at -1, 3. Remember that the formula has x minus h. A negative is a part of this form. So my h in our case is actually -1. So we're shifting to the left 1 and up 3 units. So we'll have a point here. That will be our vertex. And then we have a stretching factor of -2. This means that it opens down and it's stretched by 2 units. So we would get here and here. So our graph will look something like this. Now again, that's not a part of the problem, but I wanted to graph it for you anyway. I want you to try one. Find the standard form of f of x and then graph it. And f of x for your problem is equal to x squared minus 6x plus 8. Now, the next topic I'm going to talk about is maximum and minimum values of quadratic functions. Let f be a quadratic with standard form f of x equals a times x minus h quantity squared plus k. The maximum or minimum value of f occurs at x equals h. If a is greater than 0, then the minimum value of f is f of h equals k. If a is less than 0, then the maximum value of f is f of h equals k. It should be pretty obvious from what we've talked about already, but if you have a positive a, remember this point is at hk. That means that the x value is h, which means that the maximum or minimum always occurs at x equals h, and the y value is k. So the value of this minimum is k. And this, of course, is when a is greater than 0. When a is less than 0, we have the opposite. We have a maximum instead of a minimum. still occurs at x equals h and has a value of k. Note, the maximum or minimum value always occurs at x equals h and has a value of f of h equal to k. This is what I was stating before. The determining factor of whether you have a max or a min is a. If a is positive, then you have a minimum. If a is negative, you have a maximum. But the value of that extreme value is always going to be k. And it will always occur at x equals h. Example, suppose f of x equals x minus 3 quantity squared plus 1. Now here, we can graph this. So x minus 3 will be a parabola opening upward, and its vertex is at 3, 1. So we'll be right here. So our parabola will look like this. And we can see that we have a minimum value. And of course our a is positive, so we already knew we had a minimum value. H is equal to 3 because the negative is included in the equation in the standard form. K is equal to 1 because we have a plus k in the standard form. And a is greater than 0. This means that f has a minimum value of -1 at x equals 3. The maximum or minimum of a parabola will always be the vertex. If it opens upward, we have a minimum. If it opens downward, we have a maximum. Now let's go ahead and look at these values. If we don't want to complete the square, for the record, I think we should always complete the square, but let f of x equal ax squared plus bx plus c. Then we can complete the square with this by factoring an a out of the first two terms, and we end up with x squared plus b over a x plus blank plus c here. Now, if we are to try to figure out what this will be, we need to divide this by 2 and square it. Of course, b over a divided by 2 is b over 2a, which means b over 2a quantity squared goes here. Which means then that we subtract from c b over 2a quantity squared times a. So we will subtract a times b over 2a squared, this. And if we simplify this a bit, we end up with a times x plus b over 2a quantity squared plus c minus b squared over 4a. Here, like this. So what we're saying here is that if we can get it in this form, then we know what h and k are. Notice that we have x plus this, which means that our h is going to be negative b over 2a. Now, k is going to equal exactly this. We usually don't write it this way. We usually just write it as f of h, or f of negative b over 2a. These are all saying the same thing, but generally we write this one or this one in order to figure out where the vertex actually occurs. So let's do an example of this very quickly. Suppose that we have the function f of x equals x squared plus 12x minus 30, something like this. Then I can figure out immediately where my vertex is without having to complete the square. The vertex is going to be at x equals h, and h is negative b over 2a. So this will be negative 12 over 2 times 1, so negative 6. So my h is negative 6, and then k is f of negative b over 2a. So we're looking for f of negative 6, and that will be negative 6 quantity squared plus 12 times negative 6 minus 30. Negative 6 squared is 36, and 36 minus 30 is, of course, 6. So we get 6 minus 12 times negative 6, which is 72. and we get a negative 66. So the value, or the vertex, will be located at negative 6, negative 66. The next topic I'm going to talk about is maximum or minimum value of a quadratic function. It will be basically what we just talked about. The maximum or minimum value of a quadratic function f of x equals ax squared plus bx plus c occurs at x equals negative b over 2a. If a is greater than 0, then the minimum value is f of negative b over 2a. If a is less than 0, then the maximum value is f of negative b over 2a. Do another example. Find the maximum or minimum value of f of x is equal to 3x squared plus 12x plus 20. Now we know that it's going to be a minimum value. Our a is positive, so we know we have a minimum. Our h is equal to negative b over 2a. So here we would have negative 12 divided by 3 times 2. So we get a negative 2. Then we just need to find the actual value. So our minimum occurs at x equals negative 2, but the actual value is f of negative b over 2a, which is the same thing as f of negative 2. So we plug that in, and we get 3 times negative 2 squared plus 12 times negative 2 plus 20. So negative 2 squared is 4, 4 times 3 is 12, minus 24 plus 20. So we have 12 minus 24 is negative 12, plus 20 is positive 8. So our minimum value occurs at x equals negative 2 and has a value of 8. Try one. Find the maximum value of f of x equals negative 2x squared minus 8x plus 4. It's a similar process. Instead of finding a minimum, though, you're finding a maximum because your a is negative. Last topic we're going to talk about is modeling with quadratic equations. Here we're just going to do an example. A Taos warrior throws a spear at a droid. The height of the spear is modeled by h of t is equal to negative 5t squared plus 15t plus 8 meters. Find the maximum height that the spear reaches. Well, if we're just looking for the maximum height, all we need to find is f of negative b over 2a. This is the value, the y value of the maximum or minimum. Here we have a maximum because we have a negative a. We need to figure out what negative b over 2a is because that's where the maximum will occur. And this is, of course, negative 15 divided by 2 times negative 5, so negative 10, which will be 3 halves. Now to find the actual maximum, we just plug 3 halves into the equation. Negative 5 times 3 halves squared plus 15 times 3 halves plus 8. Negative 45 over 4 plus 45 over 2 plus 8. Negative 45 over 4 is exactly half of 45 over 2. So when you combine these two, you end up with a positive 45 over 4 plus 8, which is going to be 77 over 4 meters. This is roughly 20 meters. A little less than 20 meters. That's going to be it for today. I will see you all in the next lecture.